Hi everyone. In this lecture, we'll add functionality to the camera view. First of all, we want when users tap this image view that they can pick a photo from the photo library to share it. That's in our design. Users can actually write some captions and share the posts as a whole. Okay, let's do it. Let's open both the camera view controller Swift file and the camera storyboard. We need to connect the storyboard UI elements to the source code. We need an IB outlet for the UI image view. All right. Let's name it photo. An IB outlet for the UI text view. We can name it caption text view. For the share button, we'll need an IB outlet named share button and an IB action named share button. Share button touch up. There's a typo. Okay, touch up inside. This should be an IB action. All right, good. We need the share button property to disable the button where the post is not ready to share. All right, you can easily see that there's lots of stuff we can reuse from the sign-up view controller, such as making the image view responsive so that users can pick photos, pushing media data to the storage, and then linking it to the database, and so on. So let's begin. We'll start with the photo first. First, add a tap gesture to the image view so that it can recognize user taps. Then, change the name of the image view accordingly. All right, now change the class performing the handle selecting method in the selector to the camera view controller, as the selector will look for methods in this view controller. Also, it's better to give the handling method a more meaningful name in this situation. Then, implement this method in this view controller. All right, good. Let's see if there's any bugs. Note that, so far, we simply changed anything related to profile image to photo for consistency. And sign up to camera. Okay, we talked about this gesture stuff before. This initializer will create a tap recognizer. The target is the object which will perform the action in the selector. And action in the selector is what the target should do when a tap is recognized. In this case, we set target to self, meaning the camera view controller instance will perform the action. The selector will typically look up the action itself, so we can change this to self. If we use self, then we can avoid annoying ambiguity, like when copying and pasting stuff. So let's change everything to self. We have some selectors for text fields in the sign-up and sign-in view controllers. So let's change all those things to self. Okay. Go to the sign-in view controller and look for selector stuff, and change sign-in view controller to self. All right, good. Now, back to our business. After equipping the UI image view with a tap recognizer, we need to define what should be done after it recognizes a tap. For now, let's say we present an image picker for users to choose images from the photo library. This error is expected. The camera view controller can't be a delegate of the image picker because it hasn't conformed to some required protocols. In particular, it needs to conform to the UI image picker controller delegate and the UI navigation controller delegate. Now, as before, we need to declare a selected image like this for storage and database stuff later. All right, good. We also need to change this profile image to just photo. Let's Command B to build the app to see if there's any error. All right, great. There's no error. Let's run the app and check it out. Okay. All right, let's see. Tap the image view. Okay. All right, this one looks good. Something's wrong. Looks like the photo got scaled. Yes, indeed. This can be fixed by changing a few settings in the attribute inspector of the UI image view. In the view property of the image view, you can play around with the content mode attribute to see the effect. Here, we choose aspect fill so that the smaller side of the photos fit this target space. Let's run the app and see what this gives us. Okay. All right, let's choose a rectangular photo. All right, this one looks good. Okay, its small sides fit the image view, but the photo goes beyond the boundaries of the target area. To fix this, we can simply clip the photo to the boundaries of the image view. By doing that, anything that goes beyond the target space will be cut off. All right. Okay, let's see. Let's choose the same photo as we did before. All right, fantastic. The photo looks pretty good now, so let's see how we can push it to the storage and database. We want the share button to do that job. We can reuse some stuff from the sign up button method. We don't need to handle keyboard for now. We'll do that when working with the text view. So copy over everything except that end editing method. Okay, good. Let's start modifying the code accordingly. There's no authentication here, so delete the auth service stuff. All right. The rest gives us Firebase-friendly image data extracted from the chosen photo. Similar to what we did with the profile photo, we'll push to the storage the chosen photo in Firebase-friendly format, which is the image data. We do that by pushing the image data to the storage reference on Firebase where we want to store this photo. This is what we previously used to store profile photos. We put all profile photos in a folder under the storage root reference. Each profile photo has a relative path which we chose to be the corresponding Firebase user ID. It's like directory structure in your computer. You have a root folder with a subfolder containing all profile photos. Each is named using the current user ID. We investigate that thoroughly before. This is just a brief summary. Now, similarly, we'll also specify where on the Firebase storage we want to save this new posted photo. Under the root folder, instead of the profile image folder, we'll use a post folder to store all photos of the posts. The relative path will be a bit different. By the way, we need to import the Firebase storage library in order to use these methods. All right. The storage data shouldn't be tied up with the user information. So we need to generate some sort of ID for each post. It's up to you to choose this relative path, but make sure that it's meaningful. Okay. You can either use photo ID or photo ID string because this is just a string. Because this is like an ID, it should be unique. You can write your own function for this purpose. However, Swift offers a very convenient class for creating ID. It creates sort of strings to uniquely identify stuff. We need an instance of it. Then, convert this instance to the string format, because this Firebase method requires string inputs. Okay, there's no unwrapping here because the photo ID string is not an optional. Now, we can just copy over this snippet to put our image data to this uniquely identified storage location. Okay. There's no user information here for now. Now, after successfully saving the data to the storage, we need to extract its URL to access it if needed. and this URL should be related to our chosen photo. Then, link this image data to the database for real-time data handling. All right. Let's say we do that using a method called sendData-to-database. Okay. Let's see how we should implement this method. Actually, let's close out everything else except the camera view controller. We'll now focus on this view controller only. Okay? All right. Now we're going to implement the sendData-to-database method. This method should save to the database the URL of the chosen image data from the storage. The logic is quite similar to that of the setUserInformation method in the auth service class. Perhaps we can just copy over the implementation of this method and then modify it accordingly. Actually, we just need its body. Let's paste it here. We'll worry about code factorization if needed later. All right, let's see. Here we need Firebase Database stuff, so, as usual, we need to import the Firebase Database library. All right, the first line gives us the location of the database root location. We'll then create a kind of new directory under the root location to reference all the posts. So this constant should be something like posts reference instead of users reference. This constant then should be new post reference, which is a child node of the location of all posts. All right, for users, we use Firebase user ID for each user relative path, but for posts, we should use something else because each user can have many posts. Note that the photo ID here kind of corresponds to the photo in the storage. You can use it for the corresponding post in the database, but it's probably better not to. It might be better to distinguish between the two. All right. Okay, good. Now let's create a string ID for each new post on the database. Let's say we name it new post ID. Of course, this is going to be the string description of a child node of the all post location. This child node hasn't existed yet. We can actually create a new child node with a random ID using this childByAutoID method. The result is a uniquely identified child location of the all post reference, and the key property of this child Firebase reference produces sort of its relative path or ID in string format. So now we can tell the system that the new post location will be a child node of the all post location with this string ID. Okay, great. Now we have a database location to store the new post. Actually, this is a verbose way of creating this database location. As we're not going to use the new post ID, these steps can be compactly written using a single command. All right. But this might help you understand what's really going on. Now, we simply put data to this location using the set value of this new post reference instead of new user reference. Again, the stored data should be a dictionary. We'll need to store the photo URL. So this photo URL needs to be an input of the sendData-to-database method. This is a string, so simply say that out loud. Then use it to set the value for the photo URL key. All right, great. And don't forget to modify the function call accordingly. It now has a photo URL input. There should be an error. Let's wait for the system to catch up and see. All right. Okay, we need to unwrap the photo URL string before injecting it into this function. It's because the photo URL is an optional string, while in the sendData method, we ask for a string input. All right, good. You can actually run and test the app now. It's probably working fine. We're going to skip that though and move on to show the posting progress. All right. Let's see when we should show this success message. Of course, we should only show this message after the posting process succeeded. In particular, we do that at least after when the data was successfully stored on the database. So let's use another version of the setValue method, which allows us to do something after the process finishes. As usual, it's the one with a completion closure. The first parameter is simply the data as before. The second parameter is the closure in which we decide what to do after the process finishes. This closure itself has two parameters, which is an option error object and an option Firebase reference object. If we fail to push this URL on the database, we'll receive a non-zero error object. So, if we check the error and know that it's the case, we can simply report that to the user as we did before. And we can do that using the show error method of progress HUD. For simplicity, let's say we show the error description from Firebase, then return to skip everything below. If this is not the case, the data URL was successfully stored in the database, and we can then simply report the success message to users using progress HUD. All right. Let's say this message is success. Okay, great. We're in a pretty good shape now, so let's run the app and see. All right. Okay, let's check it out. Let's post a photo to see how it works. All right, let's see. All right, this one looks good. Let's share it. All right, this is the waiting message. Okay, fantastic. Let's check the database to see if it's indeed successful. Oh yeah, this is our new post. Let's see if this is indeed the photo we've just shared. This is basically a URL, so we can open it in a browser. All right, great. Now, let's check out the storage to see if this photo is sitting there nicely. This is the posts folder, storing all posted photos. Okay, here it is. This complicated looking string is the ID, or more precisely, the name of the file on the storage. This is exactly the photo ID string we generated in the code using this method. The data is physically on the storage, so this is kind of its name up there. We can print this out to see if it's indeed that complicated file name on the storage. One more thing before we run this app. We should also report the error if we failed to upload data to the storage. Okay, let's see. Okay. Let's open Firebase to see what's going on. Okay. Okay. Let's try posting a photo again and see. All right, let's say this one. Let's observe the real-time action. Fantastic. This is our new file URL. We can also see the new photo in the storage. It's in the post folder to be precise. Okay, this one. Its name is 032 something. In the console, we can see that it's printed out here. It's the photo ID string we printed out. All right, good. Next time, we'll work on this posting feature. Okay, see you then.